Okay, this is the P1 paper from January 2023. It's question number 11, which is last question on the paper. It's an integration question. Let's have a look at it. It says we've got a function y equals fx, and then it tells me what the second differential, f double dash x, is, and it tells me some information about the curve. So it says point P lies on the curve and has x coordinate 4. The tangent at that point is the equation y equals 3x plus 4, and asks me to find the equation of the normal. Well, I think that's all really complicated without at least drawing a quick sketch. Sketch doesn't need to be accurate, but just to give me a bit of an idea about what's going on and what I've got to try and find here. So as I say, it's not an accurate sketch at all. I don't know what that curve looks like, so I'm just going to say I've got something like this, where if this is x equals 4, this point P, they've told me, has an equation of a tangent of y equals 3x plus 4. So that's P there. That's the equation of the tangent. And then what they're asking for, I'm going to do it in a different color, they're asking to work out the equation of this normal here. Now, you don't need to draw this. I'm drawing it to explain it to people what's going on here. If I want to work out the equation of that red line, if I want to work out the equation of this normal, I need a point on the line. Well, yeah, P would be a point on the line. And I need the gradient. Well, I could work out the gradient because I know the gradient of this one is 3. I can see that from the graph. If the gradient of that one's 3, then the gradient of the normal is going to be minus 1 over 3. So I've got the gradient. Right, okay, all I need is a point P. And if I want to work out point P, this is where this sketch really helps. Point P, I know it's on the curve, but it's also on the line y equals 3x plus 4. So if it's on the line y equals 3x plus 4, and we know x is equal to 4, I've got everything I need to do now. All I need to do now is to explain all that to the examiner. So what I'm going to say to the examiner is, for point P, let's see where we get that from. For point P, we have y equals 3x plus 4, and we know that x is equal to 4. So y is going to be 3 lots of 4 plus 4, which means that's going to be, what's that, 16. Y is equal to 16 here, so I know P is the point 4, 16. And for gradient of the normal, if I'm working that one out, well, the gradient of the tangent, because it's y equals mx plus c, is just y equals 3. So the gradient of the normal is minus 1 over that. Perpendicular lines, remember, gradients and tangents and normals are perpendicular to each other. The gradient is minus 1 over the other one. So I can work out the equation of a normal. I've got everything I need to do that one. Equation of a normal, you should be really used to doing this. I'm going to use the equation of a straight line. Y minus y1 equals m. X minus x1. Whenever I do these videos, I always make it really clear what x1, y1 and m are. I think that's really good practice. So x1 and y1 are 4 and 16, and m is at this point, you just, if you hadn't spotted it and you put the gradient of 3 in, you just check and say, this is right, isn't it, this gradient bit? And obviously it is here, because I've already done the realizing it's a normal. Chuck everything in and just solve it. So we get y minus y1, so y minus 16 is equal to minus a third x minus 4. We should be really used to doing ones like this, even with fractions and with negatives. Multiply everything by 3 there. 3y minus 48 is equal to minus of x minus 4. So 3y minus 48 is minus x plus 4. And now normally they would say in the format y equals mx plus c, in the format ax plus b, y plus c equals 0. They haven't actually mentioned that in this question. So you've got a choice. I'm going to leave mine like that. X plus 3y minus 52 is equal to 4. That's the first part done. Second part is, we know f double dash x, and we're now being asked to find fx. So if you're asked to find fx, you just need to integrate it, get f dash x, integrate that again, and then we'll be able to work out what fx is. So for part B, telling the examiner, so f double dash x was 4x plus 1 over root x. All right, yeah, I can see. So what they're going to do now, in order to integrate this, we just need to tidy this up. 4x plus 1 over root x is 4x plus, we could say 1 over, if we do it really slowly, 1 over x to the half, and then 1 over x is x to the minus, isn't it? So that then becomes 4x plus x to the minus half. So I have not done any integrating yet. Let me make it clear to the examiner. I don't think I'm integrating yet. I was just getting f double dash x into a format that I can integrate. So now f dash x is integrating that. I'm going to tell the examiner what I'm doing. I'm not rushing. So 4x plus x to the minus a half. Really nice if you put the dx on there when we're doing integrating. Make it clear. Integrating, yeah, nothing complicated here. Well, certainly not the first term. Add 1 onto the power divided by the new power. Add 1 onto the power. So you should be able to do this. If you've practiced enough of these, adding 1 onto minus a half makes plus half. Dividing by the new power is then dividing by a half. And then do not forget that constant. Okay, it's really, really important. Otherwise, you mess up all the rest of your work. Let's tidy that up properly. That's 2x squared. And dividing by a half is the same as timesing by 2. To be honest with you, I'd have written that straight down for me, but I've done lots and lots of examples of this work. So that's f dash x. So they must have told me some information. I'll almost go back another read of the question here. I must know some information about it, and I do. We've been talking about it all the way through. We know the gradient is equal to 3 when x is equal to 4. So we know f dash x is equal to 3 when x is equal to 4. Remember, f dash x is the gradient function. So we know x equals, sorry, not 4, x equals 4, f dash x, I'm going to put f dash 4 actually, f dash 4 is equal to 3. We know that the gradient's 3 at that point there. So that means that 2 lots of x squared, 2 lots of 4 squared, 2 lots of 4 to the half, gosh, handwriting is all equal to that. So that means that we can work out what C is there. Don't rush it through too quickly. You can do it on the calculator. I'll do it in my head. 4 squared is 16. 2 lots of 16 is 32. 4 to the half is 2. So 2 lots of 2 is 4. Plus C is equal to 3. Yeah, so C is going to work out to be equal to minus 33. So what that means is that f dash x is equal to our 2x squared and our 2x to the half, but also minus the 33 there. And now we just have to integrate again to be able to work out fx. So fx, which is what they're actually asking me for, is the integral of all of that. Nice and slowly, just hopefully not making any mistakes. Again, if I can impress the examiner, I will do by doing things like putting the dx in there. Excuse me. So fx is equal to, add 1 onto the power divided by the new power, do that for all of them. So it's going to be 2x cubed over 3. It's going to be 2x to the, adding 1 onto a half. Don't call it 1 and a half, that's way too complicated. Do it in terms of 3 over 2, improper fractions there. 3 over 2 divided by 3 over 2. Now you could at this point times by 2/3. If you're experienced and good at these, it might be a slightly easier thing to do. Minus 33x, and again, plus another constant. I'm going to call it C again. They might call it K in the answer scheme, but I'm quite happy to do that when going through and doing my work. So I've got fx is equal to this, and I must know some information about fx. Well, again, from our previous work, we know that when x is equal to 4, y is equal to 16, and y is fx, isn't it? So we also now know x equals 4, fx, f4 is equal to 16. So that means 2 lots of 4 cubed over 3 plus 2 lots of 4 to the 3 over 2. Now, really, I should have tidied this all up. I'm not going to bother now that I've started with this, but you could have made this a bit neater before we put all this information in, but I'm not going to do the calculation anyway, you are. So going through and doing all that then, work out these values, take them all over to the other side. C works out to be equal to 284 over 3, if I write it as an improper fraction like that, And so then my final answer, fx, remember, was all of this bit from before, 2x cubed over 3. I will tidy this up now, I should have tidied it up before, so that's certainly at this stage I can't leave it. 4 over 3, x to the 3 over 2, just that thing, I'm just tidying that up there. Minus 33x, and then plus our constant, plus 284 over 3. So, really not too bad for question 11 there. I think that's a reasonable question. Certainly made a lot easier once you have a little sketch drawn out there. Otherwise, I think it's really difficult to see what's going on. But hopefully, that all makes sense to you.